These will be our last notes for Unit 1, and in these notes we're just going to be putting everything together that we have learned so far. This will also help you prepare for your summative. So in example 1, it's asking us to rewrite using exponents in simplest form. So I'm going to use simplest form, and I'm also going to solve it so that we can see both. So if I wanted to put this in simplest form exponentially, I would first convert it to exponential form, where the index becomes my denominator. And then I could simplify this to 25 and 1/2. That is the exponent in simplest form. However, if we wanted to solve this, we could also turn this back into a radical or expand it when it's in radical form. So let's do both. So we have the 4th root of 25 times the 4th root of 25. I've expanded 25 twice due to the exponent. There are no groups of 4 in 25, so this isn't going to help us. So now I'm going to go back to just converting it to radical form. 25 to the 1/2 is the same as 25 square root of 25, and that can be simplified to 5. So this is in exponential form, and this is when we solve all the way. In the second one, we'll do the same thing. In exponential form, this would be 16 to the 4/3. I can't simplify 4/3, so this would be the simplest form exponentially. But if we wanted to solve this, we could expand 16 4 times, because the radical form of this, unlike the radical form of the square root of 25, isn't going to help us. So I'm going to expand the cubed root of 16 4 times. We do that 4 times for the exponent of 4. And now I'm going to break down 16 even smaller. And because it's all the same cubed root, I'm going to put everything underneath one radical. So I know that 16 can be broken down into 4 and 4, and then that can be broken down into 2 and 2. So in total, there will be 4 2's for each of these. So I'm just going to write 4 groups of 2 4 times. And that's for this one. That's for this one. So now that we've expanded our 16s all the way, we can circle groups of 3. You'll notice we have 1, 2, 3, 4, 5 groups of 3. So I'm going to bring 2 to the 5th out, and I'm going to leave the 1 2 that was on the inside the radical, because it doesn't have 2 other 2's to group with. Now you could leave it in this form, but if we were to multiply out 2 5 times, or simply evaluate 2 to the 5th, that would give us 32 cubed root of 2. In example 3, it's asking us to prove that the following expressions are equivalent using math. So we are going to use our knowledge of exponents and radicals to do this. So the first thing is you want both to be in exponent form, because this will make it a lot easier to evaluate them, or put them both in radical form. You never want one of each. So here we have a radical and an exponent. That's not going to help us. We need to make them look the same. So I'm just going to draw a line down the middle so that we keep in mind that we're trying to see if the left side equals the right side. We know that the square root of 64 is just 8, so there's not a whole lot we have to do for that side. 2 to the 6/2 can be simplified to 2 to the 3rd. And 2 to the 3rd, I'm going to just keep bringing my 8 down, can be expanded to 2 times 2 times 2. And I know that 2 times 2 times 2 gives me 8. So yes, the left side equals the right side. This is true. In example 4, we're going to do the same thing. In this case, it's going to be easier to evaluate if we put them in a radical. So I'm going to convert this to radical form. We have the square root of 9/3. This also means we could take the square root of 9 and multiply it by itself 3 times. I know that the square root of 9 is 3, so each of these can be simplified to 3. And I know that 3 times 3 times 3 is 27. So our left side equals 27. For this statement to be true, the right side also has to equal 27. So we'll convert this into a radical. I know that I can break 27 down into 3 times 3 times 3. The cube means we're looking for groups of 3, which we have one of. So that means I can pull a 3 out. But unfortunately, 27 does not equal 3. So this statement is false. The left side does not equal the right side. In our last set of notes, this is where we're really putting everything together. We are going to be using our exponent rules, our radical rules of division, multiplication, and everything to figure out what goes in this box. So the final answer will be x to the what? We just want one x by itself. So first I'm going to convert everything into exponential form. So I know that this will become x to the 1/4. I'll leave x to the 8th as it is, 1/8 as it is, and x to the negative 3/2 as is, all over x to the 1/2. Now that everything is in exponential form, we can try and combine the exponents. In between all of our x's are multiplication. When we multiply, we know that means we can add the exponents. So the first thing we should do is get them to have the same base. Because currently we have x to the 1/4 plus 1/8 minus 3/2 all over x to the 1/2. I know that 2, 8, and 4 could all have a base of 8. Because 4 goes into 8 and so does 2. So I'm going to multiply this fraction by 2, because that'll give me a base of 8 or a denominator of 8, and I'll multiply this fraction by 4, because that will give me a denominator of 8. I'm now going to rewrite everything that I've just changed. We now have x to the 2 over 8. X to the 8th stays the same. And x to the negative 12/8. Again, all over x to the 1/2. I'm just going to rewrite this so that all the exponents are in one equation. So 2 plus 1 is going to give us 3. 3 take away 12 is going to give us negative 9. So we have x to the negative 9/8 over x to the 1/2. We know that negative 9/8 is smaller than 1/2 because it's negative, so we're going to bring it to the bottom, giving us x to the 1/2 minus negative 9/8. We know that two negatives will form to make a positive, so in the end we'll be adding them together. And then in our last step, we need to make sure that they have the same base. So I'm going to multiply 2 by 4, and this will give us x to the 4/8 plus 9/8. Four plus 9 is 13/8. So our final answer, if we were to put it in here, because there is no fraction in the answer, we would want to make this negative so that we could put it in the numerator. So the final answer here would be -13/8.